So, Lightning Network. I'd like to start with a dissection of the Lightning Network. I call it 2021 because I had previous dissections. For instance, in 2019, me and Christian Decker had a lot of discussions about how you can structure all the set of protocols related to the Lightning Network in a better way, in a more reasonable way, in order to extend them. And I was giving a presentation on the Lightning conference about dissecting the Lightning Network. And here I'm doing another attempt, which takes a lot from that time, but it adds also a lot, and it reshapes some of the things. So on the very high level, I think that Lightning Network can be presented by components related to three main topics. So Lightning Network is not a single thing. It's not even a set of protocols. It is three different families of protocols. And sometimes it's really hard because all of them are named Lightning Network, and it's really hard to understand what are you talking about when you say Lightning Network. These three families, I will encode them with a color on all the following slides, and the color encoding is that I will use blue for networking protocols, and networking protocols, they have nothing common whatsoever with payments or Bitcoin transactions. They are pure networking protocols like TCP/IP, Internet Protocol Stack. They have nothing to do with the Bitcoin and payments. I'm just emphasizing them. They're generic in this sense. Like client-side validation has nothing to do with Bitcoin and RGB. RGB and Bitcoin is application of client-side validation to Bitcoin network. The same way, Lightning Network is application of Lightning networking protocols for payments based on Bitcoin, but actually Lightning can work not only on Bitcoin, on top of Bitcoin, so it's all quite complex. Anyway, I will use blue color for networking components and networking protocols as a part of Lightning Network. I will use orange color for Bitcoin transaction-based protocols and standards. So the second family of protocols is basically how you structure the graph of Bitcoin transactions, which you can name state channel, basically. The state channel is a graph of Bitcoin transactions partially maintained off-chain. So that is actually what had original name of Lightning Network, this part, not the networking part, or Lightning channels, they were named originally. And on top of these two families of protocol, a third family of protocol is built, which is actually a payment network, which combines the elements of networking protocols and Bitcoin transaction graph and state channel transaction graph. And this is very important concept of what Lightning Network is built of, because first of all, it's really hard to dissect these protocols from each other. Some of them are spanning, the single protocol spans multiple layers. I think this time I finally was able to do this dissection and see how they can be fitted. And this is important in context of how RGB, DEX, and other sorts of functionality may be embedded into the Lightning Network. Because it's absolutely untrue, from what I know for now, to say that RGB works on top of Lightning Network. No, it doesn't. Well, first of all, which of these protocols we are talking about? And on top of some of them, RGB works, sometimes underneath of those protocols, or in between, and so on and so forth. I will be demonstrating that on slides. The other thing, the future of the Lightning Network, which I will be also discussing today, will have another colors. So on top of the networking and Bitcoin transaction protocols, you can build more than just a payment network. You can build also a data storage and data query network, like data search network, which we call Bifrost. And you can build also DEX and DeFi sort of functionality. And this will be placed next to the payment channels. But we'll also reutilize Bitcoin transaction state channels and networking layer of Lightning Network. So in the future, hopefully by the time when we will complete implementing all of that, maybe 2024, I don't know, the Lightning Network will be even more broad term than today. And to structure somehow this part and give some specific name, not to call each of them just a Lightning network of blue color or orange color, I propose this naming. So the networking layer of Lightning Network, I propose to call it Internet 2. And we already made a few projects which are related to Internet 2 of generalizing this part of the Lightning Network to support more broad applications even outside of the LNPBP ecosystem, like more efficient web APIs, microservices frameworks, and so on and so forth. The second part, orange, which is Bitcoin transaction graph, I propose just to name state channels. It's a graph of transactions which actually constitute a state channels. The payment network, let's call that Lightning Payments. And the data storage protocol, we are calling that since the very beginning, after the Giacomo idea, Bifrost. Finally, we have this DEX and DeFi extensions, which we have no name for today. Previously, we had the name of Spectrum. It was proposed by John Carvalho, but later he took that out for one of his stealth projects. And he said that we need to use some other name, but we haven't invented that name so far. And there was another name hanging around, Kaleidoscope, which Giacomo proposed to use for the first reference implementation of the RGB wallet, but we did other implementation, which we called Citadel and by Citadel. So Kaleidoscope may be used for the DEX network. I don't know. Let's discuss that. I'm not using it yet, but I will be glad to hear your feedback. Do you like this name or not? And this stack basically presents two main components. The first one is Internet 2, which is not specific to Bitcoin and Lightning Network. And the second is what we call LNP, Lightning Network Protocols, a family of all these protocols, or generalized Lightning Network, which is extended outside of the scope of Lightning payments. So this is the color coding that we will use from now on. And let's dive into dissecting Lightning Network. So Lightning protocols. So let's start with the networking part. And networking part is actually represented by 4 protocols organized in 2 layers. The first layer is encoding layer and encryption layer. Noise XK is a protocol which was invented before the Lightning Network and was used outside of the Lightning Network. Lightning Network uses its specific version, and it defines it as part of Bolt 8 standard. This protocol used for encryption and negotiation of the encryption parameters between parties. This is a very important part of Internet 2, I believe, that because it is a replacement for TLS SSL security in the Internet. The problem with the TLS SSL security is that it uses centralized certificates. It uses PKI infrastructure, and it is non-censorship resistant. Unlike it, Noise XK can be easily combined with a Web of Trust setup, and it doesn't require any DNS or any SSL TSL service. It provides you with an end-to-end encryption. So this is very important moment, which I believe have a huge future outside of the scope of payments or Lightning and Bitcoin only. The second is an encoding. I was saying that we had in client-side validation our own encoding matching our criteria, very strict criteria, that we called it strict encoding. In Lightning Network, there is other encoding. It doesn't have any name, but one part of this encoding, the most interesting part, has a name called TLV encoding, type length value encoding. Additional to that part, it's also very interesting in terms that allows you to differentiate different forms of messages with even and odd bytes, and basing on these bytes, you can introduce new functionality and add new data, new encoded data without breaking the compatibility with other nodes. So this protocol, I believe, is very efficient for networking communications. So if strict encoding is good for client-side validation, commitments, data storage, and determinism, The TLV encoding is very good for networking because of its flexibility and ability to maintain the communications between nodes, even with the evolution of the protocol. In RGB, we can't evolve, we can't change. So that's completely different trade-offs for encoding. So TLV encoding have a lot of application outside of the scope of the Lightning Network itself. And for instance, we use this encoding standard for universal Bitcoin invoices, which we introduced a few months ago, covering not only Lightning Network invoices, but also Bitcoin, Miniscript, partially signed Bitcoin transaction-based invoices, and RGB. And these two bottom layers of this networking protocol, again, they have nothing to do with the Bitcoin and Lightning. And other than Lightning is just using them. And on top of them, we have two other layers, which I call P2P messaging and features layer. P2P messaging defined in the bold 1, and features is the bold 9. Basically, these layers define a set of messages which nodes in some P2P network may exchange, and features define how they can negotiate the set of supported features. So I call these two protocols, and I call this layer a generic P2P network. And such generic P2P network, again, it doesn't contain any information inside those messages about Bitcoin transactions, Lightning Network, channels, whatsoever. You just run peer nodes in the network talking to each other in certain format. And there is even a proposal by Jonas Schnelli from Bitcoin Core, who see that we can build a similar system for Bitcoin nodes, for Bitcoin P2P network. Of course, the same architecture, the same pattern can be used for building a better BitTorrent or other P2P distributed services. And that's why I'm calling all of that Internet 2. And we plan to build all the stuff that we are building on top of these protocols, which will extend not only Lightning networks, but more generic P2P protocols. The second block on the same level, right next to the networking, is state channels. And state channels may be of different sorts. And I would say that there are two main sorts, payment channels, and there are also non-payment channels. I will be briefly talking about them next. And payment channels, even payment channels, may be different. So today, what we call Lightning Network is in fact payment state channels based on penalty, or so-called Poon, Drija, Decker, Wattenhoff channels. They basically based on the replacement of the signed Bitcoin transactions with the new versions and maintaining history with the signed Bitcoin transaction, a special penalty mechanism if the channel is closed in non-cooperative way with a previous state, not the latest state. So that's what is called Lightning Network today. But the Lightning Network can work with different forms of payment channels, like L2, the proposed L2, which will combine well with the Schnorr signatures, but unfortunately it requires a fork of soft fork, another soft fork, so it will take many more years to be implemented and finalized. And in addition to that, you can construct multi-party channels. So these are bidirectional, bi-party or dual party channels. I mean, the penalty based on L2, but you can do multi-party channels, which we plan to use in certain scenarios. Additionally to payment channels, with the Lightning Network, there is possibility for other forms of channels, like DLC channels for discrete log contracts. There are several proposals already. Channels for doing more complex form of computing and storage inside the state channel off-chain, which we call Storm and Prometheus. And in some distant future, maybe we will work on the implementation, or hopefully somebody else will start doing that. I wouldn't be spending time on that right now, and we wouldn't be discussing them today at all. I'm just demonstrating the concept that state channels are much behind payments, and there are multiple ways of constructing pretty much advanced state channels. On top of the layer of state channels, also related to Bitcoin transaction graph, there is another set of protocols and a family of protocols, which are called coordinated updates to a transaction set. So basically, how you can coordinate updates to state channels between different state channels. How you can untightly bound state channels together. That basically a building block for routed payments. But we are not having payments here yet at all. We are not having routing here at all. At this level, we have two mechanisms proposed today for atomic binding of different channel updates. HTLC, hash time lock contracts, and a replacement for them PTLC, which will require Schnorr signatures. And fortunately, with the introduction of Taproot to Lightning Network, we will be finally able to bring PTLCs to life. PTLCs is payment locked contracts. Basically, instead of hashes, you're using electric curve points to do the same atomic binding, and they are proposed by the same guys who do DLC shared bit guys. Next to that level, on the same second level, there is a transaction structure modifier protocols. Protocols defining how transaction structure should be modified. So the PTLC and HTLC is about how you can coordinate modification to independent transaction graph. Here, this protocol is about how you can, if you have a transaction graph in your state channel, how you can modify transaction graph, because you have symmetric transaction graph by all two participants of the channel, how you can modify it simultaneously by both of participants. And these are extensions to transaction structure defined by penalty lightning channels. And these extensions are proposed as a form of feature bits. Today we have two of them implemented in the Lightning Network, anchors and custom shutdown scripts. And there is third proposal currently being reviewed, and there is work in progress in C Lightning, which I know about on implementing it. It's a channel splicing. So basically you can insert the transaction, publish one transaction on chain and splice the channel. So this, and in the future, I believe there will be much more protocols at this block on this level. On top of that, we are building the third layer, first layer related to channels. And this layer is basically payments scoped to a single channel. We don't have routing here. We don't have multi-hop payments here. It's basically how you can update the state of the channel between two parties. And this layer is the first layer merging networking layer and Bitcoin transaction graph related protocols. What it consists of channel control API defined by Bolt 2. And this API says how you can open a channel, update channel state, modify channel state, and close. By modification, I mean, for instance, splicing channel. So it's not update to the balance, but update to the transaction structure and on-chain status of different transactions inside the channel, and closing channel. So this is a basic Lightning Network that will allow you to open a channel and pay to other party, but you wouldn't be able to pay to the party which you don't have a direct channel with. So for that, you need another family of protocols, starting with a layer inserted between the channel, scoped API, and networking, which is called Sphinx Onion Message Routing. And at that level, you define the generic messaging. We already have a proposal, which is accepted, for how you can send not a payment, but any piece of information over the Lightning Network. So you can see this Lightning Network created by the networking protocols like NoiseXK and so on and so forth as an overlay network, Tor-like network. And you can use it for normal information exchange. And again, because this is of the blue color, it has nothing to do with the payments or Bitcoin transactions or anything like that. It's just a messaging layer where you can encrypt, you can send message with a multiple hops without exposing message data. using onion encryption. So it's a Tor alternative. And on top of that, combined with a channel scoped API, you can do a routed payments. So routed payments is basically extension to generic messaging, in which, of course, initially we had routed payments, then we had general messaging historically, but from the protocol design level of view, the routed payments is the extension of generic messaging. And we have Onion API, which is built, I don't remember, 5 or something, 6 maybe, which is another standard. But that's not the end of the story, because to do the multi-hop payment, you have to do route calculation. And originally, Lightning Network was supplied with a single protocol at that level called, it was called know-how, it had no name. But later there were more proposals like trampoline routing. So I believe there will be more proposals. So this is clearly a family also of protocols residing its own top level. However, how you can route if you don't know the network of the map of the network? So here you have nothing that can help you with understanding how the Lightning Network structured. And that's why you have another protocol called Gossiping API, P2P API protocol, which is Bolt 7, if I'm not wrong. And with that, finally, you have what you call Lightning Network today. So I dissected all of it, of the current state and pending proposals to the Lightning Network and some future applications into this structure. This is all on the state of things. Next, I will be telling you how we can do a plastic surgery with RGB and then DEX and everything else. But before that, maybe some questions on this part of the story.
I know there was a question about the Internet 2 naming. So if the question is still there, I would ask the author of the question to raise it.
Well,
yeah,
in the
sorry,
meantime,
I'm very far from my
go.
unmute button. Yeah, just to let you know, there actually is something which exists for many, many years, which is called the Internet 2, so maybe you should reconsider the naming.
Is it an organizational protocol? What has that name?
It's a real network that exists, which is called the Internet 2, which connects universities all around the world, independent from the Internet 1.
Interesting. Can you share more information about that?
If you search on Wikipedia or even on Google just for Internet 2, you will find their website and all the information. It was actually a project that started after the internet became commercial to give again the power to the universities and the non-commercial use for the network, and they created this alternative network.
Interesting, thank you. Well, it was mostly funny name. Like there is this Web3 so-called initiative, which actually says it's about decentralization, but it's know-how about decentralization. So me and Giacomo, we were thinking on the name and invented this Internet 2 as Internet 2 is not Web3, something like that. Yeah, Giacomo, you was also going to say something.
Okay, yeah, no, it was more like if I compare this kind of taxonomy with the kind of taxonomy that, for example, I remember Shinobi published about splitting up the Lightning Network into channels and punishment and routing and stuff. Well, I think this is mostly consistent with what I was imagining already. But what was the main changes that you applied in respect to 2019? Basically, it is the tripartite structure with the networking part that we're also discussing sometimes privately. So you are basically taking the networking part out, and you are distributing in these 3 ways instead of 2, instead of being bidimensional like in 2019, right?
Yeah, probably correct, because the only change here is, first, more details because new protocols appeared. Second, we got one missing structure. So before this here, we had this part, and it was really ugly to set it up and explain, because like, oh, something is missing there. But finally it came in, and it allowed to make it more consistent. And the last thing, I was trying to put all the networking protocols together, like here, but it didn't work well. So I understood that actually networking layer is not like, it's different layers. They just related to the networking. So these are the only changes. But it was also Chris Ticker and probably Shinobi who was also putting, which were also putting routing on top. So it's not a new thing in introduction. It's more like me finally accepting that truth. Otherwise, yes, it follows the original Christian Decker idea, which he published, and other concepts. It just adds some details and new protocols, which helps that make even more consistent.
Just a curiosity. Did you try to put the BP layer with that as well? Does it breaks everything, or it still makes sense if you consider the base layer as well?
It doesn't breaks anything. So basically, BP layer can consist of 2 things. Like, I will just add it right here. Sorry. So that's all.
Okay. Well, with the fact that, yeah, there's a nice fact that in order to, I mean, a Bitcoin client doesn't just have to compose and read Bitcoin transactions, but also to synchronize with other peers to validate blocks, and that will connect with the network part based on the Jonas-Nally hypothesis.
Yeah, correct. And the only thing that today it uses some custom network format for Bitcoin peer network, for Electrum, and so on. So there is some Bitcoin networking, but it's so ugly, and it desires replacement, because all this JSON RPC APIs, all these non-encrypted Bitcoin node communications, they're really faulty by design. And basically, it would be very nice just to replace that with this set of protocols. And the perfect thing will look like that. And that's what actually we're trying to do. So with the BP node that we are doing, we will use this networking for providing information about mine transactions, indexing as a replacement for Electrum, and potentially in the future for Bitcoin node P2P networking as well. And then we will have this complete picture. So yeah, Lightning is much more than Bitcoin. Bitcoin is much simpler and smaller comparing to it.
There's another question. Bifrost versus Storm, how do they relate?
Yeah, I will go to Bifrost in the next slides, and I will address the question on that route. Really briefly, Bifrost is a data distribution network, mostly. First, it's network, and it's more about data distribution, but also about data storage. The Storm is a specific state channel that helps you to incentivize and make it trustless a long-term data storage. And it's not networking protocol. So basically, Bifrost will be blue, and Storm is orange. So they are the same like the Lightning networking protocols comparing to Lightning networking state channel protocols. Okay, probably I will move further, and we will continue with the questions after the next slides. There are really one slide left and few textual and a description of it. So now plastic surgery first with RGB, next with Bifrost, and finally with DEX. With RGB, we need to do a really very few things. First of all, we have to apply another transaction structure modifier next to anchors and shutdown. And this modifier will be signaled with features. So we introduce a feature flag, which is already, we are allowed to do that by the Bolt9 standard, saying that this feature flag signals support for RGB. And when the other node indicates the support, you basically, by default, apply a special modifier to the structure of Bitcoin transactions, which we call, which does nothing else than allows you to commit to client-side validated data and tweak public keys. And that's all. So you're signaling that you're tweaking public keys. So that's quite simple part. The next thing that we should do is sorry, it's not perfect animation. I will just change a few things right on the go. Because it's related to the next question. So the other thing you have to do for RGB, additionally to features and transaction commitments, you need to introduce a new message to the channel control API, which I call funding message. And this message allows you to inform that you add RGB funds to the channel, because basically you add RGB funds to existing channels. You are not opening RGB channel from the very beginning. So at the connection level, when you connect to other node, the node signals support for RGB, you create a normal Bitcoin channel, and then you add funds to that normal Bitcoin channel or pre-existing Bitcoin channel with this additional message. And this message delivers information about how the consignment related to that funds can be retrieved directly or through Bifrost network, or you can embed the consignment to the message. Right now, we are just embedding it, but once Bifrost part will be ready, we will be using that API to deliver consignment data, because usually it wouldn't fit the size of the Lightning Network message, which is restricted to 64 kilobytes. That's all, and we have RGB in the Lightning. No more modifications whatsoever. You just need to write the Lightning node supporting RGB, and that's all. So from the protocol level, from the standard modification level, it's very simple surgery. Which is more advanced is Lightning Bifrost. And before moving to Lightning Bifrost, let me do another surgery right on the slide. I have to talk about light speed, because it's not directly related to the RGB itself, but it is very much related to other parts of DEX and Bifrost functionality. So what is light speed? Light speed is a protocol that allows you to utilize client-side validated data, RGB-based client-side validated data, to do payments over inside the Lightning channel without signatures. And you can't route those payments. It's only for a single channel, but you can have a very high frequency of payments, and you can link payment with network requests. So for instance, you are asking your peer, another Lightning node, about, do you have consignment for me? And you can pay with that request. Not as a separate Lightning payment, but you can bound payment to the data request. Or you can do a search or other forms of queries. You can use that in constructing maps of the Lightning network in Trampoline or in other forms of messages. So this Lightning is a very, very handy toolkit, just based on RGB. And what it requires is extension of the channel control API with a set of few messages, and that's all. Yeah, and basically another modification of the transaction structure. Additionally to light speed, there is a thing which is called RGB-LC, temporarily, I don't know how to name it. It's basically the thing that is utilized by light speed, how you create this unsigned payments. So I can't go into technical details on that part. There is a proposal for Lightspeed, and probably best thing would be to read it for all those who are interested in this protocol. If we will dig for the Lightspeed here, we will see it's LNPBP 33 in form of that discussion. So you're welcome to read it, and you will see this micropayment transaction, which I call this RGB-LC. So these extensions, it's a modification of transaction set, and it allows you to coordinate updates between two parties. So these two things are quite, I wouldn't say that it's hard to add them. They are not harder than the adding of the RGB support, and they are independent from RGB itself. They need RGB, but they can be added later. And from here, I finally can move to the Bifrost. Bifrost doesn't require RGB to be present, so I can even remove these parts, and this will still work. But of course, it can be enhanced with the Lightspeed payments, because you can add incentivization for Bifrost, and you can add new revenue model for Lightning nodes. Again, you introduce a new feature flag. You create a new protocol which is called Bifrost P2P API, and this protocol extends the set of messages that can be sent over the Lightning network. So you can connect to any Lightning node. You don't need to have a channel with that node. You pick node that you like to. You send a message to that node. Init message, normal Lightning init message. You indicate with a feature flag that you're interested in Bifrost functionality, and the node can answer with that. Also, you will know about Bifrost enabled nodes from the gossiping, because part of the protocol is that each node publish information about its feature flags. And Bifrost protocol support, as well as RGB protocol support and Lightspeed protocol support, will be a feature flag in that information. So you will see from the route, from the map of the network, which nodes support Bifrost, and you then can connect to them and send Bifrost-specific queries the same way you're sending queries to open a channel to do something. And the final thing that is needed for Bifrost is a payment coupling, for which I have a special dedicated slide, and I will explain what it is. So first of all, starting with what Bifrost do, what it will do. I see at least 7 tasks that can be efficiently covered by Bifrost as a part of Lightning Network and an extension to the Lightning Network functionality. So first of all, we can pass RGB consignments during payments to the receiver, because we need to send the client-side validated data. And this can work even for on-chain payments. So it's not needed only for Lightning payments. You can use Lightning Network infrastructure and functionality without opening channels, without doing Lightning payment, to deliver client-side validated data for on-chain payments or other forms of RGB operations. That's the first task. Directly from the payer to the receiver. You can also publish and distribute data on RGB assets. So if you are an issuer and you publish asset, you will publish it to the Bifrost network, and Bifrost nodes will just exchange this information, and any other node can ask Bifrost node, what assets do you know? And you will be provided with a list of assets. And to protect from spam, again, just combine that with the Lightspeed payments, pay some small satoshis or sub-satoshis for this request, and get your data. So here you're starting building a search network, decentralized search network out of the Lightning network. So you are able to query for the data, pay for that query, and you have the distributed database about these RGB assets maintained by network, incentivized by these Lightspeed payments. The next thing you can do is you can reuse the same process for decentralized name resolution. Again, big topic. There was a presentation on how you can build a decentralized DNS using RGB, and we have a schema for that, RGB24. It's mostly complete. And the part of this story is the Bifrost network on top of Lightning network, where you publish your registered names, and you can query this network about name resolution. And this enhances, basically, when combined with a noise XK, it adds the ability to replace DNS with a human readable names, not just only keys, and it provides you with what Tor is not able to provide with. Next, if you can pass consignments direct, you can also store these consignments for third parties in encrypted form. And of course, the party that will be storing the consignment has to pay for that in front. Otherwise, it's like with watchtowers, which are actually another application of Bifrost network, because you can really simplify the API for watchtowers and combine the Lightning native watchtowers, which with RGB specific information about Lightning channels. Finally, you need to back up encrypted form of client-side validated data, and you can use Bifrost for that. And you don't need even to introduce a new protocol, because what you are doing is you create a data, you take your stash, RGB stash, you split it into small blocks as a form of RGB container, and you pay with the light speed for the storage of this data in distributed way. So this can be a data storage network. And why only RGB stashes? You can do that for generic data storage. And here, finally, we are coming, I was constantly talking about Lightspeed, because Lightspeed allows you to pay for a single request or short-term storage, like I'm asking you to store this consignment for 1 day, or I'm asking you to store this my encrypted RGB stash for many, many years, but I will be pinging you each hour, providing you with micro payment, checking that you are keep maintaining the copy of my data. So this is all what can be done by Bifrost and Lightspeed only. However, you can enhance this thing into long-term storage with a Storm. So Storm is a form of state channel which incentivizes somebody to store the data long-term, and you wouldn't need to ping and constantly check that. You have the stake of both parties protecting you from different non-cooperative closings of that channel. And Bifrost will be just a networking layer that able you to communicate and open that kinds of Storm channels. Again, there is a Storm proposal. Those who are interested in Storm can go to LNPBP standard site and look for Storm and read it here, how it works. Okay, so that's Bifrost what can do. Now, more details about this final part, which is required for Bifrost implementation, which is, I don't have a name for that. I call it message payment atomic coupling. Basically, how you can couple the request to store some data or retrieve some data or query some information with admin, such that if server have performed your request, the server is guaranteed to execute, guaranteed to be paid. And I already described this functionality. This is based on Lightspeed and this RGB LCs, which I was talking about. And the same mechanism will be used in case of DEX, which is the final part of today's talk. So we have all of that in place. We have RGB Lightspeed here. I removed Bifrost because I don't have space here on slide, just because of that. And now I will stick in the DEX. So the DEX basically will take the same place, exactly the same place as the same layer. You just add another API, peer-to-peer API. You know which nodes in the Lightning Network operate as a DEX. And you don't need, in terms of how you can compute the route for some exchange. The original idea that we had is that we need to publish the exchange rate as a gossip messaging, but it will create a huge traffic for the Lightning Network and will be very inefficient. Instead of doing that, what we are now propose is because we know which nodes support DEX, and we know which assets and how many liquidity in that assets they have. It's already part of the gossiping and Lightning Network. We don't need to change and add anything there. We construct the route, which is of our interest, and we directly connect to the DEX nodes that we are interested in, which have sufficient liquidity. And these nodes just answer us about their current rate. Just connect, what is your rate? This rate, that's all. And then you construct the payments that goes through the circuit containing these exchanges on the route. And they do this exchange on the route. Of course, they will need RGB, otherwise you can't add other assets to the Lightning Network. So today, Lightning Network, while being multiple asset by the design, is de facto single asset because you have only Bitcoin. Nobody uses Litecoin there. And with RGB, you will be able to bring multiple assets to the Lightning Network, and that's what will allow the DEX functionality. There is one problem with DEX, which is a well-known problem, a reverse American colon problem. But this problem can be fixed by doing so-called multi-coupling. So like we had a coupling of request and a single payment with a Lightspeed and RGB-LC, we can do an HTLC or PTLC-based coupling between two Lightning payments. So to solve reverse American call option problem, you will be paying to the DEX node, and you will be bounding the payment for DEX exchange operation with a certain stake that party puts if something goes wrong. So basically create a proper economic incentive such that no matter how the payment will pass, it will pass or fail, the incentive is set in such a way that the attack to the network will be impossible. So with that coupling, we solve the final problem that prevents us from building the DEX. This multi-payment coupling is not completed yet. It's not described anywhere. It came from the discussions that I have with Christian Decker, and last week I was discussing it once again. I hope that over the next few weeks we will be able to come to some formal description of how this can and will work. So that's all. I already said about that. And the roadmap that we already have described with the Bifrost part added. So once we will have all RGB layers finalized and released to the main, to the production, like I wouldn't say that to the production, but meaning that we freeze the API and we are ready to the audit and it's completely test covered and all schemata are completed. Completing the integration with the Lightning Network and these surgical updates to the Lightning Network, which are listed here. We will work on the Bifrost implementation in this sequence, starting from sending RGB payments, publishing information about assets, then storing the consignment for third parties, watchtowers, and generic data storage backup API. And after that, so I do believe that this and this will take till the end of this year. I don't know, I wouldn't promise anything. And the next steps will be building the DEX functionality on top of that, which will require these changes to the Lightning Network. We will need more generic channel structure negotiation, so you can create more complex form of channels than just the payment channels. Probably we will need multi-party channels, which can enable such things as liquidity pools, then do these couplings, which I was describing, and implement the parts of the DEX like P2P message APIs. And on top of that, you start building things like liquidity pools, algorithmical stablecoins, DLCs with derivatives, options, futures, and so on and so forth. So there is some long-term future for RGB. I'm talking not about the next year, I'm talking about several years from now, which will be the second version of RGB. Well, before the second version, we will probably do a contracting language, which will allow you to write custom RGB smart contracts with very advanced functionality, which will be probably required for options and futures. And the second version of RGB, coming after the several years of the first version, will probably contain switch from pay to contract to sign to contract single-use seals. We'll have something with a bulletproof aggregation and nimble cut through zero knowledge improvements, and maybe it will have a dedicated commitment layer additional to Bitcoin network for scalability purposes, which wouldn't have a native currency. It will be just cryptographic commitment layer in Wimble style, but it's very early thoughts on that matter. That's all for today. Thank you very much. It was much longer than I expected. Again, I missed all the terms that I was thinking that I will be able to fit in.
Thank you, Maxim. That was a comment. So Giacomo left the call, but he left a comment. The comment is, some other interesting Bitcoin-related uses of Bifrost may be channel backup and script descriptor backup for complex on-chain stuff. Maybe you can comment on that.
Correct, absolutely, that's true. I haven't explicitly stated them, but I was thinking about when I was saying backups. So it's client-side validated data backups plus state channel backups plus Bitcoin descriptor wallet backups. So backups containing not a private key, but the structure of descriptor defining specific use of the keys that you own. That's correct.
There's also a comment that Bifrost and Lightspeed are very interesting for utilization in the future. Max, maybe you want to elaborate on that a bit?
Yeah, again, Maxim, excellent presentation and keynote there. I was very curious on the actual implementation of Bifrost and Lightspeed. I did also share a few posts that I saw you guys put in bitcoinerjobs.co, very similar for what I posted as well. I encourage everybody to go and check that out, especially for trying to get some more developers to be implementing a few of the things we're talking about. But specifically, I am visualizing how Bifrost and Lightspeed could be implemented for what Olga very briefly and shared with you a couple, I think it was a week ago or a couple of weeks ago at this point. But essentially what my project is focusing on is being able to distribute CAD files or 3D printable files back and forth via Lightning Network and utilizing RGB. So I do find Lightspeed very interesting for how I could possibly over at us at Eden be able to implement that. So again, I encourage everybody to go and check those out. So there is opportunities as well for people. Of course, we can't pay absolute high six-figure developer numbers, unfortunately, not yet. But I definitely encourage people to go and check those out and see how we can tackle a lot of these issues and implementations from many different angles.
Thanks. It will be interesting to check that. I think you can start even without Lightspeed. You can, because Lightspeed is about super fast and frequent payments. If you are just buying content like 3D printed files, you can use normal Lightning payment. The Lightspeed is when you need to do like 1 million requests per second or something. For instance, if you are building distributed Google over the Lightning Network with a Bifrost, you will need Lightspeed. Otherwise, or even you need to couple the request with the payment. Yeah, that's probably maybe the the requirement for the stuff you're talking about. I think Bifrost and RGB in Lightning Network is much more tangible. So RGB is working on Lightning Network already. What we need to complete the RGB with Lightning Network is Lightning Network part. So we need to complete the Lightning node implementation that we have, LNP node, towards the full Bitcoin functionality. So that's not far down the road. The only thing that can postpone that is that we are finalizing on-chain part first. The next thing, the Bifrost will come after very fast after that. Lightspeed may take more time, and it will be the next thing we will work on once we will have Bifrost and RGB. So hopefully this may help you. How somebody can help with that? Well, we need to finalize Lightning node implementation. Not sure is it easy to help, because when people, it has very detailed architecture, and you have to know Lightning Network. So it's hard to find a developer who already knows Lightning Network, Rust, and able to spend sufficient time on understanding how the LNP node works. So I expect that probably the first release of LNP node will have to be done by me, after which it will be much easier to maintain it with the community support once the core functionality is developed.
Excellent point. Thank you for answering and commenting on that. Thank you.
Thank you.
Any other questions, guys?
If there's no other questions, I want to make another comment, kind of a question, or kind of a blend of both. But I did speak with, this is quite a while ago at this point, at the MIT, I think Crypto Economics Summit with Andrew Polstra regarding Miniscript. So I will do my best to reach out to Polstra. Again, I know he's very busy with many other things, but I'll reach out to him via PGP and see what his thoughts are on implementing, whatever the best course of action is for this particular application. So, and any thoughts on who else would be beneficial for that?
Well, Andrew, I'm quite closely working with Andrew. Like, we are communicating maybe each next day. He is aware that Miniscript is not a Lightning Network, and he has no resources to help with that. It's like he's saying, whoever wants to add Miniscript into the Lightning Network, he can help with implementing necessary parts in Miniscript libraries if needed, but actually it's not needed yet. It's more about writing the spec for Lightning and RFC, and it's not untrivial. It's quite trivial to write it down. Basically, what you need to do is to get the script from the current spec, convert it into Miniscript, and paste that Miniscript in. That's all have to be done. Well, you have, of course, see that and check that everything went smoothly, but basically it's something like that. Taproot would be more complex, probably. The persons who may be interested in that, it could be Matt Corallo, for instance, Anthony Riard, but I don't know what about their timelines. Would they have time to work on that? Like, there are plenty of people who are interested. Christian Decker interested, Rusty Russell interested. Everybody is interested, but nobody have time.
Yeah, exactly. We need eyes on the code and comments underneath for review, and more especially more actual fingers to keyboard on yourself to give a little more cushion for you. I know you're doing a tremendous amount of work on the actual coding side, so just trying to think of who else to reach out to. So that's excellent to hear that you're already in dialogue with Polstra. I'll ask. I'm sure Matt Corallo already is well aware of all this, but I'll reach out to him regarding just his thoughts and comments on that, and maybe if he does not have time, maybe he could suggest somebody that would be of quality, particularly for this.
Okay, thank you very much. Thank you. Thank you for staying with us such a long time. It's been 2 hours already. Crazy. I was thinking that it will take 40 minutes.
Time flies when you're having fun.
Yeah.
So if there are, okay, Tricola, come on, speak up. Do you have a question also, or you wanted just to say thank you? Ah, okay. So if there are no questions now, I think we can wrap this up. I'll upload all the information as usual to our website, and I'll send the links to the RGB Telegram chat and on Twitter. Thank you, Maxim, for a great presentation. Thank you guys for being with us for such a long time.
Thank you very much.
Have a great day. See you next time.
Thank you very much. See you guys.
Bye.
Thank you.
Bye-bye.
Bye, everybody.